Looking at various ratios of sides of right triangles leads to some of the most important ratios in all of mathematics. In some sense, the ratios that so much of mathematics hinges on. Those are the trigonometric ones. So let's take a look at a right triangle. And notice that, in fact, if I think of the angles as being the capital letters A, B, C, and the lengths of the sides being the lowercase letters, just to remind you, the lowercase letter A is always going to be the side that's opposite the angle capital A, so we can always identify where things are. Sometimes that's going to be important. C, the hypotenuse here, is going to actually be opposite the 90-degree angle, and little b is opposite this angle, capital B. Well, it turns out if we look at the various ratios of sides, they somehow generate important quantities. And we're going to see the importance of that coming up. But let me introduce you to the three basic ratios. They're called sine, cosine, and tangent. And just to sort of summarize, or to sort of show it to you really fast, when I think about sine, I just think about opposite over hypotenuse. That's how I remember it. So what does that mean? If you want to find the sine of an angle, so let's suppose we're taking a look at an angle here. Let's say the angle A right here. If you want to find the sine of the angle A, what you do is you look at the ratio of the opposite leg, that's little a, divided by the hypotenuse, that's C. And so we see A over C. If you want to find the sine of the angle B, then what you do is you consider the opposite leg of B, which is little b, divided by the hypotenuse. But it's always, for either of these acute angles, the sine of an acute angle is always going to be the opposite divided by the hypotenuse. That's how I remember. That's the little code in my head that actually allows me to remember this. Now the cosine's a little bit different. It's the adjacent divided by the hypotenuse. So for example, the cosine of the angle A, this acute angle, is going to be the adjacent side, which notice is B, divided by the hypotenuse C. So B over C. What would it be for B? The cosine of B would be adjacent over hypotenuse. That would be this adjacent side, which is A, divided by the hypotenuse. So adjacent leg divided by the hypotenuse, it should be A over C, and it is. Excellent. And finally, the tangent is a great one. The tangent for an acute angle is going to be the opposite leg divided by the adjacent leg. So opposite divided by the adjacent. So in this case, opposite A divided by the adjacent B. And so it's A over B. And for B, it's going to be opposite B divided by A, B over A. These three ratios are so important, and as we start to study them, you'll appreciate how valuable these things are in practice. Now, just to get a sense of what's going on here and to practice this a little bit, let's try some on our own. So let's take a look at this triangle. This is a famous 3, 4, 5 right triangle, and I want us to write down the sine of A, the cosine of A, and the tangent of B, and what I want us to do is when we have to, we'll just round to the nearest 100th, okay? So it's not a big deal. So sine of A. Here's A, and what's sine? Sine is opposite leg over hypotenuse, so it's going to be the ratio 3 over 5. And so this equals 3 over 5, which is just 0.6 as a decimal. What about the cosine of A? So we're still at A, looking for the cosine. That's going to be the adjacent leg over the hypotenuse, so that's going to be 4 over 5. And so I see 4 over 5, which if you either long divide or just multiply top and bottom by 2, I see is 0.8. Okay? And finally, what's tangent of B? Oh, B. So we jump to B. Tangent. That's opposite over adjacent. So that's going to be the opposite leg over the adjacent leg. That's 4 divided by 3. So that's 4 divided by 3, which if you divide that out, you see 1.33. And it's actually 333 forever, but I'm rounding, so 1.33. Absolutely neat. These trig functions are so valuable. These ratios are important, and you're going to see it coming up soon, that these are the trig functions of our lives.